All right, guys. So again, welcome back, everybody. I hope you have a nice day so far, and let's jump in. Okay, so let me take my keypad off. All right. So, hope you guys remember what was the topic that we discussed yesterday. One of the topic that we discussed yesterday was significant figures. So we are going to kind of build up on that. Again, I'm gonna turn my camera off. I'm gonna try right on the screen. So stop video. All right. So I hope you guys remember the rules. Let me just ask you: do you guys remember the rules? How to find out significant figures in the given number? Do you still remember the rules?
Yeah.
Yes.
Have it.
Everyone, do you remember that?
No.
Oh, all right, no problem.
Yes.
All right, let's just quickly go back and look at the rule. This is very important. All right, so what are the rule for the significant figure? The first rule is if number is less than one, it means it's like 0 point something. In that case, all the zero before your first non-zero digit are not significant figure. It means if you have a number like this, in this case this is your first non-zero number, which is number 2. So everything before that, like all the zero before that, are not going to be considered as significant figure. So answer for this number, how many significant figure are there? You can say it is going to be 3. So 1, 2, and 3. The second rule, right, if the number is greater than 1, so it's not just one condition, there is two conditions that need to be matched. First, it has to be greater than 1, and second is it should not have any decimal point in it. So for example, if I have 110, for example, right, if this number, if we are looking at this number, we can see it is more than 1 because it's 110. Also, we do not see any decimal place in this, right? In that case, what we can say, all the trailing zero means the zero on the right side of the number, or that, or we can say on the tail side, are not going to be considered as significant figure. In this case, this is only 1 0 which we have on the right side, so we cannot consider 0 as significant figure. In this case, the answer is going to be 2. All right, and these are the two rules that you apply to even the number given in a scientific notation form, right? If I give you a scientific notation, you are still going to apply the same rule, but the only part is that, let's say, let me just write that down. For example, right, of course this is not going to be like this. Okay, let's say if you're going to apply the rule, you can apply the rule to the actual number and just ignore this part. All right, the multiplication and 10 to the power, just ignore this part, apply the rule to this number, right? The rule that we already learned. Is that good? Was it
Yeah.
helpful to refresh your
Yes,
memory?
Professor. Yeah.
Yep.
All right, wonderful, wonderful, great, guys. All right, we already discussed this, so I'm not gonna spend time on this once again. But you remember, I gave you an exercise yesterday saying that, okay, do the multiplication and share your answer in the chat box. You guys did a wonderful job. You all share your answers with that. Uh, in that case, if you remember, you were all getting a different number digits, right? So why is that? That is the purpose of having a significant figure. So what is the rule for the significant figures? How many digit that should be if you're doing any math problem? So there is a rule. The rule says for multiplication division, right? If you are just multiplying two numbers or three numbers or five numbers, or if you're dividing that, or even if you're doing multiplication and division together, right? For example, if you are doing any of this, your answer must have fewest significant figures from the given numbers. It means, for example, the first example we have here, right? What I'm asking you to do is I'm asking you to multiply 0.235 with 7.2, right? I'm going to let you do it. I'm going to give you 15 seconds. All right. Please do this multiplication and let me know what your answer is in the chat box. Right, that's Great. I can see some of your answers. Yep. It looks like 1.692, right? So let's just say if you do the math, you will get a number like this 1.692, which is, of course, right. But the purpose of this discussion is to learn what actually we should put. The rule, what it says, if you have multiplication and division, or just multiplication or just division, what you have to do, you have to have your answer which has fewest significant figures from the given number. So we have to check how many significant figures are there in this given number. All right, so let me ask you, how many significant figures do you see in the first number that we have here?
Three.
Three.
All right, that's great, right? Yes, that's right. For the second number, how many significant figure do you see?
Two.
Wonderful, right? So that's two. Now, if we're looking at this, there is three significant figure in the first number. There is two significant figure in the second number. Which one is the fewest or smallest? Of course, two, right? What does it mean? It means your answer must have only two significant figures. Now let's compare our answer. How many significant figure do we have right now in our answer?
That's just four.
Four.
Significant
Four.
figure is one, two, three, and four.
Four.
Yeah.
Yeah.
Yes.
So we have four significant figures. And what we just learned, we learned that it has to have the fewest significant figures. It means it has to have only two significant figures. So when you write your answer must be 1.7. Why? Because it has to have only two significant figures. Two significant figure means you are going to get rid of the last digit and the second to the last digit. But in this case, I think you may know how to round off. Do you guys know what is round off?
Yes.
Yeah.
Yes.
Yeah.
Yes, Professor.
Everyone, yeah?
Yes, sir.
Okay. All right. So I won't spend time on explaining you that. So round off it basically, like, you're getting off the last few digit to get actually how many numbers you need, right? How many digits you need. In this case, we just need two digit. So it should be 1.6. The number that you are trying to get rid of, it is 9. When the number is greater than 5, like 5 or greater than that, you're just going to add plus 1 to the number that you're going to retain. All right, that is basically called rounding off. So in this case, instead of 1.6, we're just going to add plus 1 to 6, so 7. So 1.7 is your correct answer in terms of significant figures. So you must write down your answer as 1.7. Does it make sense?
Yes.
Yep. Yeah.
So if it was 1.63, would we say 1.6?
No, even if you say 1.63, okay, yes, sorry. Yes, if it say 1.63, then your answer must be 1.6,
Okay.
because the number the digit that you're getting off is less than 5. It means you don't have to add any number to the retained digit, right?
Yes, sir.
Sounds good, everybody?
Yes.
Yes.
Okay, wonderful.
Yes.
Yeah, Professor.
Great. Thank you, guys. All right. So same, like, I'm not going to ask you to do this math. It is very simple, but I'm going to explain you this, right? Once again, if you're dividing this number, right? If you're dividing these two number, all you got to do is find out how many significant figures are there. So I think it's a good practice to kind of, find out how many significant figures are there. So let me ask you this. How many significant figure do you see in the first number?
Two.
Two.
Five.
Two.
Five.
Five.
Oh.
Perfect. Five.
Two.
All right.
Yes.
Number is greater than 1 and it has a decimal place. All right, so we are going to count these zeros. All right, the rule was number has to be greater than 1, and if does not have any decimal place, then we're going to ignore the trailing zeros, right? In this case, we do have a decimal place, so we are going to count these zeros. All right, so yes, it is 5. In the second number, how many significant figure do you see?
Three.
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 Everyone? 3. That's great. All right. So yes, it is 3. So when you do the math, right, you don't have to do the math right now, but whenever you do the math, your final answer must have 3 significant figures. All right, it should not have 5, it should not have 4, it should not have 2. All right, so keep that in mind. Do you understand this rule?
Yes. Yes.
Everyone, you? Okay.
Yes,
One.
Professor.
Okay, that's awesome. All right. Now, as I just told you, it is about multiplication or division or both, right? The same way, if it's addition and subtraction or just addition or just subtraction, what is the rule? The rule says you have to have the fewest decimal point from the given number. It means how many digits you have after the decimal place, that does matter. All right, whichever number has least number of decimal place, that's how you should supposed to have your answer in. All right, so in this case, instead of asking you about how many significant figure are there, I'm going to ask you how many digit do you see after the decimal place.
3.
All right, I think
3.
everyone can see this, right? It's simple. So yes, it is 3. The same way, how many digit do you see after decimal place in this one? One.
1.
Right? Just one digit. What does it mean? It means your answer must have only one digit after decimal place. So let's say if you do the addition in here, so 5, 3, 4, and 7, right? If you do the math, this is what you get. But as you know, your answer must have only one digit after decimal place. It means you are going to write your answer as 7.4. Again, you are applying the rule of rounding off, because the number that you have here is 3, which is less than 5. You are not going to add plus 1, like you're not going to add 1 to the retained digit. Does it make sense?
Yes, sir.
Yes.
Yes, sir.
Everyone, does it make sense? Yeah.
Yeah.
Yeah. Yes, Professor.
Okay, great. So remember this rule, all right? If it's multiplication or division, you have to have fewest significant figures from the given number. That should be your answer. If it's addition and subtraction, right? When you're doing this math, like addition or subtraction or just one of this, you have to remember your answer must have fewest decimal point from the given number. All right, if you remember this, you're definitely going to be, it's going to be like 3 to 4, like maybe like 2 point question as a multiple choice question, maybe 4 point multiple choice question. It is definitely going to be there in your first exam. All right, so please. Sorry.
I was having trouble logging in. I kind of just got here. Just to like reiterate, so you just round to the nearest decimal is what you're saying?
uh, what I said is depending on what numbers you have. Let's say in this case, that is, this is the first number, this is the second number, and you are doing subtraction, right? So if it's addition or subtraction or both of them, what you're going to look at it, you're going to find out how many digits you have after decimal place. In the first number, you have 3 digit after the decimal place. In the second number, you have 4 digit after the decimal place. That's right.
Yes.
All right, so in that case, when you do the math, your answer must have the fewest decimal place from the given number. It means your answer must have only 3 digit after decimal place. It should have only 3 digit.
I see. Thank you.
Get it? No problem. All right, everybody's clear?
Professor, for the division
Yes.
one,
Yeah?
so would you write it as, so I got 0.43902. So since we need,
0.43902, right?
so we would write it as 0.439.
Yes, three significant figures, so yes.
Okay, thank you.
Okay, no problem.
And so Professor, for that also that's like the same that we did yesterday, right? Those significant figures.
Oh yes, that's the same rule, right? So for addition, like multiplication and division, what we are saying is we are going to look at the significant figures, and we know how to look at it, right? We already look at the rule earlier today, right? So we should find out how many significant figure in the given number one, how many significant figures in the given number two. If there are 5 given numbers, you're gonna check all 5 and see how many significant figures you have in each of them. Whichever has the least number of significant figure, that should be your answer, right? So your answer should have only that many significant figures. That rule apply to multiplication and division. If you're multiplying or dividing or both of them, you apply that rule. But if you're doing addition or subtraction, if you're adding something, subtracting something, in that case you have to look at the number and you just need to find out how many digits you have after the decimal place in the given numbers. Whichever number has least digit of the after the decimal place, that's that many digit you should have in your final answer after decimal place. Is that clear?
Yes.
Everybody, can we move on? Yeah.
Yes.
Okay.
Yes.
Okay, great. All right, so we did talk about this a little bit, but I think today we have more time to kind of explore this a little bit more. So I am going to, like, I have already given you in the next slide, I have the problem on both of this density and specific heat, so we can talk about that in the next slide. But in this slide we can talk about the temperature unit conversion. All right, so I hope you guys remember there are three different units for the temperature that we're going to learn for in this course. One is degree Celsius, second is degree Fahrenheit, and third one is
Kelvin.
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 Alvin.
awesome. All right, do not say degree Kelvin, then you are not my student then. All right, remember it is Kelvin, not degree Kelvin. All right, and these are the three formulas, 1, 2, and 3. Right, this is either way you can write it in this format or the other one. These are the three formula which you can use to convert this unit into one another. Right, for example, in this case, let me just give you a question that you can practice right now. Let's say if I'm saying that there is the temperature is 25 degrees Celsius outside because today is really nice weather. So I'm asking you, what is the temperature in Kelvin? All right, I'm gonna give you 1 minute, I think, which is more than enough to find out the answer. All right, let me know what is the temperature in Kelvin if the temperature in degrees Celsius is 25. You should find out which formula to use and then plug in the value. You have 1 minute to solve this.
298.15.
All right, I'm just going to wait for 30 more seconds. I want everybody to try, okay? It's simple math. Find out which one of these three formula you're gonna use and then just simply plug into numbers. This is awesome. All right, great guys. So yes, you can look at this. What you're trying to convert, you're trying to convert degrees Celsius into Kelvin. If you look at the formula, the first formula has the relation between Kelvin and degrees Celsius. So what you're gonna do, you're simply going to plug in the value. Instead of Celsius, you're just going to plug in the value. What is that? In this problem, it is 25 plus 273.15. So the answer is going to be 298.15. All right, many
Uh,
times depending on, sorry,
Professor, I'd like to say something.
yeah, go ahead.
In the specific heat, the unit is calorie per gram and degree Celsius, but it's supposed to be in Kelvin, right?
It's supposed to what?
It's supposed to be in Kelvin, right? In the
Mm,
specific heat, the unit.
no, it can be in degrees Celsius, it can be in Kelvin. Most of the time in
All
this
right, all
course
right,
we are using degrees Celsius for this course, right? But it also can be in Kelvin, that is right as well.
all right. Thank you.
Okay, no problem. All right, so yes, you are simply going to plug in this number and find out the answer. All right, let me just give you one more example and see if you can, like, I'll give you two more anyway, and let's see if you can, work on this. All right, so in this case, what I'm saying is giving you temperature is 38 degrees Celsius, and I'm asking you to find out what is going to be that in degree Fahrenheit. So that's the one problem. The second problem I want to give it to you is, let's say that Fahrenheit is 110 degree Fahrenheit. Let me know what is that temperature in degrees Celsius. All right, so this is problem A. Problem B, what I'm gonna do, I'm just gonna let you kind of process this, let you know, like let you decide which formula you want to use and apply that. I'm gonna give you like 3 minutes for this because you may need little more time than the previous one. So I'm gonna give you 3 minutes. Take your time, make sure you use the right formula, and I'll I'll wait for your answer. All right. So you had 3 minutes to solve this.
Do we need to write the answer in like this the significant figure way, or
Uh, if you want to, then yes. If you don't want to, it's fine. The idea here, like actually, you should, but at least for now, because we are just learning this to how to apply this formula and how to do the math. If you don't want to write, think about significant figure, it's fine as well.
okay.
All right, but it's a good practice if you can write down all the answer in correct number of significant figures. All right, it's a good practice. All right, guys. Do you guys need more time?
No.
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 Ahmad, yes, I have recorded the lecture and I'm going to I will share the recording with you. All right, with like basically with everybody. All right, so okay, great. So I think you guys had enough time to solve this. So I'm just going to show you one more time to how to find out the answer, how to plug it correctly in the formula. At the same time, before we talk about that, I want to mention that if you are wondering that how to write this number in a correct number of significant figures, keep in mind the always you have to write in a correct number of significant figure. Let's say if you have to write in a correct number of significant figures, you always have to look at how many significant figure has been given in the question. All right, so in this question, if I say like 38 degrees Celsius, it has two significant figures. It means your answer must have two significant figures. All right, in why? Because in this formulas, right, the number that you see here, which is actually working as a constant, right, this number is considered as constant number. And if it's a constant number, you are not going to consider that how many significant figures they have. Okay, you are going to learn this more in detail in the lecture. This number is called exact number. All right, this is called exact number. What is exact number means? Any constant, right? If you have any constant, that is considered as exact number. If I'm going to tell you how many oranges are there, you can just simply count it, right? You don't have to use any scale, or you don't have to measure anything. to just find out how many oranges are there. So those number is considered as exact number. Any constant value is considered as exact number. All right. Measured number is different. Measured number means anything that you need a scale for, right? If you need some sort of measurement to get that number, then we can call it as a measured number. And the significant figure rule only apply to the measured number. All right, that is a very minor detail. You are going to learn that in the lecture. It's not, it is important, but it's not something that I think we should spend time on at the moment. So that's why I did not go in the detail with that. But at least I'm telling you right now that if you have any number like this in this formula, 1.8, 32, 1.8, and 273.15, this all number is considered as exact number. It is a constant number. And if you are trying to find out your answer in correct number of significant figures, you do not look at this number to write your answer. All right, just see how many significant figures you have in the question, and that many numbers you should have in your answer. All right, in this case, all right, of course, in this case, right, when you do the math, they generally do not ask you, like in exam, they do not ask you to write down your answer in correct number of significant figures, or instead of giving you like two numbers, we will provide you like 20.21 degrees Celsius, find out what is the temperature in Kelvin, something like this, which you already have four significant figures. So if you write your answer in such a way, then it is fine. All right, so in that question, I will not give you 25, I will rather give you 20.21 or something like that in terms of temperature. All right, the value I'm going to give you, it will definitely have more than three or four significant figures, so you don't have to kind of convert this into scientific notation. All right, do you guys understand this?
Yes, sir. Thank you.
Yes.
Yeah.
Are you gonna explain where
Yes,
the
Professor.
formulas came from in the lecture?
Sorry.
Are you gonna explain where the formulas come from in the lecture?
This formula has been known, so there is nothing I can do about, like I cannot explain you where this came from. It has been kind of developed by scientists, and we just should need to plug in the numbers to find out the values. All right.
Okay.
Yeah, I can explain you these formulas because it explain you with the unit, but this formula is just like a math. 1 plus 1 is equal to 2. Why? Can anybody explain that? Probably not, right? Because everybody think that 1 plus 1 is 2. Why is not 3? It just, that's what we learn, something like that. All right, and this formula has been developed throughout like many experiments, so it's just a constant number of formulas. All right, so let's just try to solve one of this problem. All right, I think A is kind of easy, so I'm just going to solve problem number B, in which I have given you the temperature in degree Fahrenheit and I'm asking you in degrees Celsius. All right, so for this, to make it easier for us, we can use formula number 3. Why? Because it says degree Celsius on one side of the equation and degree Fahrenheit and everything else on the other side. So this way it's kind of easier for us to plug in the values. So in this case, degree Celsius, because that's what we need to find out. Degree Fahrenheit value is going to be 110. So instead of degree Fahrenheit, you're just going to plug in the value. You're going to subtract that with 32, and it says divide by 1.8. So it is, you're dividing the whole number with 1.8, right? So if what you have to do, you simply has to subtract this number and divide this, and that should be your answer. Sounds good?
Yes.
Yes.
Find
Yeah.
out the answer. Can you write down the answer, please?
You do you have the answer? I didn't do the math.
No, I want to see. So is the answer is just 1 point, one decimal after the point, right?
Let
Professor,
me
the
do the
answer
math.
is 43.33.
It is 43.33. 43.33.
That's what I got.
Okay, then your answer should be, if you want to write down in a correct number of significant figure, it should be 43.3. This is your answer. All right, why? Because I told you 32 is considered as exact number, 1.8 is considered as exact number because these are the constant value. So your final answer must have that many significant figures which you have in the question. The question has three significant figures. Let's say I'm going to give you like this, right? It has three significant figure, so it should have three significant figures in your answer as well.
I'm sorry, can you explain what do you mean by constant value?
Constant value means if let's say if I'm going to give you all right, how do I say that? Okay, you know, I think you may know this. The value of pi, do you guys know what is the value of pi?
3.14.
8.14.
Right? What is that? So that is a constant. Everybody knows that is the value, right? 3.14. So that is called constant. The same way, if you have some formula, something like this, in which the number has been given, degree Celsius plus 273.15. In this formula, this is constant. It's not going to change at all, right? No matter where you, if you're in Europe or in US or anywhere else. This is the formula. That's what everybody learn in like all over the world. So this is a constant number which has been developed by, of course, scientists by doing so many experiments, right? So this is known as constant number. If it's a constant number, we are going to consider them as exact number. And if it's exact number, we do not count them as significant figures. So in this case, we shouldn't worry about how many significant figures are there. The same thing we can apply to 1.8 and 32 in this formula.
So the numbers that are in the formula, they're insignificant.
Yes, they are insignificant for our calculation. Yes. All right. Sounds good. Any more question?
No, sir.
No, Professor.
Okay. All right. So moving on, what is the density? All right. So let me just explain you that in the next slide. All right. What is the density? Have you ever heard this term before? Anybody?
Yes.
Yeah.
Yes.
Okay. So you may know that density is basically how much weight or how much mass a compound or any substance has in the given volume. All right. So the mass in the given volume, that's what it called as a density. So let's say if I'm gonna ask you, if I'm gonna give you this same size of the piece of let's say iron and cotton, right? The weight of this piece could be what? Maybe like 10 grams. So what do you think the weight of this piece could be? Cotton would be more than 10 or less than 10?
Less than 10.
0.1 grams.
Yes.
Right? Of course, really lower than 10, right? So let's just say it is 1 gram, for example, right? What does it mean? It means even though it has the same volume, right? The size, you see the volume, right? It is equal, but the mass in the iron is very much, right? It is like maybe like 10 times more or maybe 15 times more than cotton. What does it mean? It means iron has higher density than cotton, and cotton has lower density compared to iron. All right, so basically what is density means? Density means how much mass it has in the given volume. That's why the formula for the density is considered as how much mass it has in given volume or per volume. All right, can you remember this formula?
Yes, Professor. Yes.
All right, and what should be the unit of the density then? All we're going to do, we're just going to know the formula, right? What is the formula for density? It is mass over volume. So the formula, the unit should be what? The mass. What is the unit of mass? Generally, we use grams for the to measurement as a mass, right?
Yes.
And volume, we generally measure in ml. So the unit of density could be gram per ml. This is one of the unit. It also can be gram per centimeter cube. Centimeter cube is another way to measure the volume. All right, you are going to learn this more in detail in the lecture, but this is what you can keep in mind, right? If you have a solid substance, right, if you are measuring the density of any solid, in general, like, we use gram per centimeter cube as a unit. All right, if you're using any liquid, if you're finding out the density of any liquid, we generally use gram per ml. All right, again, you don't have to remember this. All you gotta remember is the unit of the density could be like the gram per ml, or it also can be gram per centimeter cube. One point I do want you to remember is what is the relationship between ml and centimeter cube. So it's not hard, it is same. 1 centimeter cube is equal to 1 ml. All right, so either you write gram per ml or you write gram per centimeter cube. It is right, it is not incorrect, it is the same thing. Do you understand this?
Yes.
Right.
Yes, Professor.
Great. So please remember this relation, right? Actually, I forgot to put that down in the first handout. So you can add this relation to the, like, or equality factor, you can say, in the first handout where you have the equality factors given, right? 1 centimeter cube is equal to 1 ml. All right. It is going to be very helpful. Okay. So in this case, right, I think if I'm going to ask you a question in which I'm going to give you the mass, and if I'm going to give you the volume, you can find out the density. All right, so let me just give you a simple example before we actually work on the given problem. All right, so let's say the iron, right, iron cube, right, has a mass of 23.40 gram, and it has a volume of, let's just say, 12.1 centimeter cube. All right, can you find out what is going to be the density of this? Find out the density of the iron cube. I gave you the number for mass, I gave you the number for volume. Can you find out the density? Yes, can you?
Yes,
Yes.
Professor.
Okay, that's great. I'm just gonna explain you this right now because I wanna explain you like more challenging way, that how to solve this problem. All right, this is kind of easy problem. What you know, the density. What is the formula for density? How much mass we have in given volume. So this is actually the formula for density. If you have the value for mass, which you have in this case, 23.40 grams, and if you have the value for volume, which is 12.1 centimeter cube, all you have to do is divide this two number and get your answer, right? The unit is going to be what? Gram per centimeter cube. Does it make sense? This is
Yes.
how you can find out the density. If you want to find out the density, you need to know the mass and you need to know the volume. If those two number you have, then you just simply plug in the value in the formula and you get the answer. Everybody understand this part?
So, Professor, so I got like 1.93388. When do I know like when to stop?
Right, so if you have something like this, what we're going to do, you are going to apply the rule of the significant figures that we just learned earlier today. What function you are doing, what mathematical expression you are doing, you are dividing these two number, right? You see this, you are dividing this two number. If you are dividing, what should be your answer? What was the rule that we learned? If there is a division,
Please.
1.93.
what was the rule? But
Multiplication and division, you need to use the least number of significant figures.
yes, right. So if you have multiplication or division, your answer must have least number of significant figures from the given number. So we need to find out how many significant figures we have in this two given number. How many significant figure do you see on the number that we have on the top?
4
4.
4 and 3.
and 3 at the bottom.
and 3 at the bottom. So the least significant figures we have is 3. So your answer must have only 3 significant figures. So your answer must be 1.93. Do you get it?
Yes.
Yes.
Yes, Professor.
Yeah, great, wonderful. All right, so yes, this is really easy problem. All you gotta do is plug in the value in the formula and you get the answer. But this is something more challenging that I wanna kind of go over right now. All right, I know it may not be that challenging for some of you guys, but some of you maybe it's a little bit more challenging. What we have here, what we have is, let's say if you have compound that has mass of 9.2 grams. All right, so mass is something you already have, right? Mass is 9.02 gram and the density is 1.45 gram per ml. The density value has been given to you, which is 1.45 gram per ml. What do you need to find out? You need to find out what is the value of volume. All right, do you understand the question, everybody?
Yes.
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 Okay, so of course when we're going to solve this, we know this formula: density is equal to mass over volume. But in this case, what do we need to find out? We need to find out volume. So if we have to find out something which is in a denominator, right? I would just like, of course, if you guys know it, it's great. If you guys having trouble finding out, okay, let's do one thing. I'm gonna give you 1 minute. All right, before I'm gonna explain you, I think I should give you 1 minute to try it, and please mention your answer in the chat box. All right, let's see how many of you can get the right answer. Right, it's not something, even if you get wrong, it is completely fine. All right, but I just want to see what you guys know. All right, so it seems like most of you guys kind of know it, right? But I still want to explain you this, that you know how to solve this. Again, if you know this and if you know the way you can work out on this, follow the method you like. Just in case if somebody doesn't know how to do this, what I will say, if you have a formula like this, right, in which you have the uh, like a value like density is equal to m over v. We can call this: d is density, m is mass, v is volume. Right, if you have something like this, what, and if you have to find out something which is in denominator, right, I think the best thing to do is, remember, you can cross multiply these numbers, right? This can go on the top and this can go in the bottom on the opposite side of this equal sign. So if you want to shuffle or rearrange this equation, you can do that in such a way. It could be v equal m over d. Do you guys understand this? This is the math, and which is right. Okay, doing this is not incorrect. Just keep in mind, you can cross multiply this. Basically, the one on the denominator can go on the numerator side on the other side of the equal sign, and the one which is on the numerator side, that can go in a denominator on the opposite side of the equal sign. Do you understand this part?
Yes, sir.
Yes.
All right,
Yes.
just in
Yes.
case if you do not know that, you can do this, and this could be the formula which you can use to get your answer. All right. One more thing that I want to mention is either you can do this, right? Let's say D equal M over V. So you can rearrange this formula in a way that you're moving V in the place of D and you're moving D in place of V. So you can write this way. This is right. Also, right, what you can do, you can just move one of this, the one in the denominator, on this side. So it could be this dv equal m, right? D and v is together on this side. Let me just rewrite this. D equal m over v. We are just moving v on the top, because if you have something in a denominator and if that's the value you have to find, sometimes it is kind of troublesome for some of the students. So you can just simplify this formula like this. All right, and once you simplify the formula, you just need to rearrange it. Okay, so you can use this formula. In this case, what we have, we need to find out v, right? So it means we want to isolate v. What we want to do is to isolate v, we are going to divide this by d on the both side of the equation. This two cancels out, so finally we get this formula. Do you guys understand this part?
I have
Yeah.
a question. So I just wanted to clear myself up. So it's
Mhm.
basically you have to multiply the mass time the density to get the volume.
No, you have to, you see, this is the formula, right? You have to divide the mass with the value of the
Divided.
density.
Okay, and if I want to find the mass, do I do the same thing?
If you just want to find out the mass, then you can use something like this, right? You can just use this formula. So there is, it's called shuffling of equation. There is two way to shuffle the equation. Either you can, you can move this on the bottom and you can move this on the top, or you can just do one of this. So you can just move this on the top, right? If you do that, it means it's density multiplied by volume equal mass. So if you want to find out the value of mass, this is what you can do. You can just move the denominator on the opposite side of the numerator. So this is the formula you can use to find out the value for mass. Do you understand?
Yes, thank you, Professor.
Yeah.
Yes.
Everyone, is it helpful?
Yes.
Professor.
I have
Yes.
a quick
Right.
question.
Very much, Professor. Thank you.
Yeah, no problem.
To
Right.
find a mass, do you just times density times volume and then it equals mass, right?
Yeah, if you want to find out the mass, then yes, density times volume is going to give you the value of the mass. Yeah.
Thank you.
Okay. Okay, great, great. No problem. So I think I do not have any more space to kind of solve the problem, but what I can do, I can just ask you to work on this, right? As I told you, you can shuffle the equation. This is the equation that you know. You can shuffle the equation like this, which is V equal to M over D, and you can just apply the number in this formula and solve that, right? I think you guys write like 6.22, which I believe it should be the right answer. So M, the value for M is 9.02. The value for density we have in this question is 1.45, right? If you divide this number, yes, it could be like 6.22. All right. And what is the unit? Always remember, you have to write the unit in this course, right? Even if you're talking about 110 or 201, you have to write the unit. All right. There is just one quantity which does not have any unit. Everything other than that has a unit. All right. What is that? The specific gravity. Right. We are not going to talk about this in detail. You will learn in the lecture, but you can remember this specific gravity. It is the one of the measurement which does not have any unit. Everything other than this has some sort of unit. All right. Are we guys clear? Yeah,
You
go
said
ahead.
specific gravity doesn't have any unit?
Yeah, specific gravity does not have any unit. So if I have to explain you this formula, the specific gravity is equal to density, right? The density of any substance. So for example, let's say we are talking about iron. So density of iron divided by density of water. All right. So if you are dividing the density by the density, right, it means you cancel out the unit, right? The density of iron, the unit could be gram per ml. Density of water, the unit is going to be gram per ml. So basically you're canceling out the unit. That's why specific gravity does not have any unit. And the formula for specific gravity is equal to density of any substance divided by density of water. So if you find out the density of any substance and if you divide that by the density of water, the number you're going to get, that is called specific gravity.
Now this substance is just liquids though, right?
No, it can be anything, right? It could be iron, it could be like, it could be solid, it could be liquid, it could be gas. All right.
Yes, Professor.
Any question?
No, Professor.
No.
Okay. All right. So the goal of solving this problem was to explain you can shuffle the equation in such a way, right? In the second form, like in the next slide. Oops. What happened? I cannot. Sorry, guys. My screen has frozen. So just give me 1 minute. I can't do anything. Just give me 1 minute. I need to attach my keypad. Okay. All right. So you guys can see the problem, right? The new problem.
Yes.
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 Right. So what is specific heat? All right, remember the one that we talked about earlier, just before like a minute, that was specific gravity, right? That is different. What is specific heat? I'm going to explain you term. I'm going to explain you the formula. I'm going to explain the unit. And again, I'm going to explain you how to kind of shuffle the equation. All right. So first of all, what is specific heat? Specific heat means, let's just assume you have any given material, right? Let's just assume water right now. The quantity of the water is 1 gram and the temperature is 22 degrees Celsius, for example. All right. So what is specific heat? It is amount of the heat that requires to increase the temperature of 1 gram of substance. It could be any substance. In this example, we took water. 1 gram of substance by 1 degree Celsius, or it could be Kelvin. Okay. It means, let's say if I'm going to give you 1 gram of water and I'm going to tell you that, okay, the temperature is 22 degrees Celsius. Now you have to turn on the heat, and you have to turn on the heat up to when until it reaches to 23 degrees Celsius. And if I'm going to ask you to find out how much heat did you apply to that water to increase the temperature by 1 degree Celsius, then that amount of the heat is called specific heat. Is that clear?
Yes.
Yes.
Can you repeat that, please?
Sure. So basically, what is specific heat? Specific heat means how much heat requires to increase the temperature of 1 gram of substance by 1 degree Celsius. So it could be any substance, right? I simply give you the example of water, but it could be any other substance. Even if for iron, let's say if I give you a piece of the iron which weight about like 1 gram. And if you measure, like let's say if you use the thermometer to measure the temperature, and it says like 25 degrees Celsius for now. So I'm gonna tell you that, okay, put it on a heat until it reaches to 26. And if you do that, now I'm asking you to find out how much heat did you provide to that iron cube so that it reaches to temp, like it goes up by 1 degree Celsius, right? The temperature goes up by 1 degree Celsius. That the amount of the heat that actually you provided, that is called specific heat for that particular substance. So for water is different, for iron is different, for cotton is different, for everything it is different. All right, for every solution it is going to be different. Make sense?
Yes, thank you.
Is it always by 1 degree Celsius?
Yes, or you
Okay.
can say 1 Kelvin.
One
All
Kelvin.
right, most of the time in this course we use degree Celsius as a unit, but in exam, like if I'm going to give you like temperature in Kelvin, then you can use that Kelvin as a unit. That is completely fine. All right, so based on what we just talked about, we can say what is going to be the formula for specific heat. So I'm just going to use abbreviation as H. That is not actually right, but it's just because I do not have more space here. So I'm just going to use SH, which is specific heat. The formula is amount of the heat required to increase the temperature of 1 gram of substance by 1 degree Celsius. So the formula, or I would say the unit, is going to be like this. What is going to be the formula? The formula is heat. Let me just write that down. Heat divided by mass, because we talk about, right, 1 gram of substance, and increase the temperature by 1 degree Celsius. So change in the temperature, because you have two value of the temperature. You have the temperature before you heat it up and after you heat it up. So the formula for specific heat is heat divided by mass multiplied by delta T. Delta T means change in the temperature. So if I'm going to tell you that it is 22 degrees Celsius and now it is 23, so what is going to be delta T? Delta T is going to be 23 minus 22 equals 1 degree Celsius. It means the difference between the two temperature. Does it make sense?
Yes, Professor.
Everybody?
Yes.
Yes.
All right. Of course, do not worry about this. You are going to learn a lot more in detail in the lecture. My idea was to explain you how you can shuffle the equation. All right. That's the purpose why I'm explaining you this. But before I explain you this, of course, you should have a basic understanding of this. And if I'm going to ask you the unit, what should be the unit? So let's just see. Heat. What are the unit for the heat or energy? We learned that, right? Heat, or we can use term energy. It's the same thing. All right.
Calorie?
Yep. Either we can call it as a calorie or we can call it as a joule, right? So it could be calorie or joule, depending on what unit has been given to you in the question. Over mass. How do we measure the mass? Generally in grams, right? So generally in grams. And delta T, change in the temperature, it must be in degrees Celsius. Like I wouldn't say must be, I would say like it could be in degrees Celsius or it could be in Kelvin. So either it could be just degrees Celsius or you can just replace that with Kelvin. So this is the unit of specific heat. Do you understand this?
Yes.
Yes.
Yes, Professor.
Yes, everybody?
Yes.
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 All right.
Yes, Professor.
Okay, that's great. That's great. All right. So as long as you know the definition, as long as you know the formula, you definitely can find out what is the unit going to be. All right. With that said, let's focus on the problem. Right. Again, my idea is to explain you how to shuffle the equation, which I already did earlier. So I think this would be easier for you to understand. The question says, how much heat is required? It means we have to find out heat. When you read the question, it is very important that the way you read the question. All right, so I'm just gonna show you the way I like to read the question. I just like to kind of highlight every point that is important and kind of ignore everything else which is not even important to solve the problem. So what we need to find out, we need to find out heat, right? What is the quantity given? 23.3 grams of metal rod, right? Doesn't matter what it is, We just need to focus on the number 23.3 grams. To increase the temperature from 22 degrees Celsius, okay, there's a mistake, that should be degrees Celsius, to 28 degrees Celsius. We are changing the temperature from 22 to 28. All right. So let me just highlight the oops. Okay. Let me just point out the details that we have. Mass 23.3 grams, right? Heat is something we have to find out. So it's a question mark. The delta T. What is delta T? It is always final temperature minus initial temperature. All right. So remember this. Whenever you find change in temperature or change in anything else, it is always has to be final temperature minus initial temperature. So sometimes you may see a negative number, right? You are going to learn that when we talk about the energy in the lecture, but at the moment we just need to focus on this. So it is always T2 minus T1. What is T2? It is final temperature. It end up with 28. So 28 is the final, minus T1, it is the initial, which is 22 degrees Celsius. So the answer for this is 6 degrees Celsius. All right. We are going to, like, you are going to encounter a couple of problems in the course in which you may see a delta T, which is a negative number. That is also a possibility. That's why I'm trying to explain you this. It is always T2 minus T1. Do you remember this?
Yes, sir.
Yes, Professor.
Okay, great.
Yes, Professor.
Yes.
Wonderful. And the specific heat value, right? We have, it says if the specific heat of the metal rod is this, so it has been given to you. So specific heat is given to you 1.67 calorie over gram degree Celsius. All right. What formula do we know? The formula that we know for specific heat is heat over mass times delta T. In this case, what we see that we need to find this value out, and we have the value of SH, we have the value of mass, and we did find out value of delta T. Everybody following me?
Yes.
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 Right? So what we had to do, we just need to shuffle the equation once again. That is the goal of this problem, right? Solving this problem is not hard as long as you know how to shuffle the equation. So what did I told you? I told you that you can shuffle the equation, and like there's two way. Either you can just multiply one of this, like bring the denominator from the one side of the equation to the numerator on the other side of the equation. You can do that, or you can just cross multiply this both to exchange their space, right? Exchange their location. In this case, because we want to find out heat, the best thing for us to do is just to move this decimal place, sorry, just to move this denominator onto the numerator side on the opposite side of the equation. Do you follow me?
Cross multiplication.
Sorry?
So you mean cross multiplication?
Yes, cross multiply, like what I mean is you're just moving the mass. Okay, let me just write this down. All right, there is two ways to do this. I'm just gonna use abbreviation, which is not right, but I'm just gonna do it because of the space. So one thing what you can do is you can kind of cross multiply the denominator to the numerator on the other side, right? If we do this, it is going to look like this: specific heat multiplied by m multiplied by delta T is equal to heat. This is the one way to do it. The other way to do it is you cross multiply both of this, right? So you exchange this space. So it should be what? M and delta T goes on the top while specific heat goes in the bottom. You follow me?
Yes, sir.
Yes.
Everyone?
Yes, Professor.
All right. So let me just tell you this. If you want to find out something which is in a nominator, right? If you have to find out something which is in a numerator, you have to do this, the first one. All right. Why? Because doing this step, right, just moving your denominator to the numerator on the opposite side, you can isolate your h, right? You can find out what you need to find out. Everything else in the is on the opposite side of the equation. All right, that's what you can do. If you have to find out something which is in a numerator, you're just going to move your numerator to the, sorry, move your denominator to numerator on the opposite side. In case if you have to find out something which is in a denominator, in that case what you can do the cross multiplication of the both one, right? So this goes on the top and this goes in the bottom. This is what you can do. Does it make sense?
Are
Yeah.
we going to do examples with the denominator?
Can you repeat the question?
Are we going to do an example to find a denominator?
We did earlier, right? You remember the volume, the one that we did before? Right?
Oh, okay. So
That's
the same
what we did.
concept.
Yeah, right? You remember we did that, right? We cross multiply both of this in order to find out something which is in a denominator, right?
I see.
Yeah, in this problem, what we need to find out, we need to find out something which is in the top already. So for that, we just need to move the denominator on the opposite side to the numerator. In this case, the formula is going to look like this. SH, we are just moving this on the opposite side on the numerator. So SH, we're gonna mass delta T equal to heat. This is the formula which we're going to use. Everybody understand this? Yes?
Yes.
Yes.
Any
Yes,
question,
sir.
any confusion?
Professor, question. His specific, let me see, specific hit
Yeah.
multiplied by mass and
Delta T.
delta T
Yeah,
is equal heat.
that's right. Yes.
All right, good.
Yeah. All right. So once you know how to solve this equation properly, depending on what you need to find out, it is simple. Now you just need to plug in the value. Do you have the value of specific heat? Yes, you do. Right. It is 1.67. When you plug in the value, you should also write the units just so you understand that you are plugging this value correctly. Right. So the unit is calorie over gram degree Celsius. What is the mass? The value of mass is 23.3 grams. And the value of delta T, we did find out, which is 6 degrees Celsius, right? That is going to give you the value of heat. By doing this, you know degree Celsius is in a numerator and denominator cancels out. Gram on a numerator, denominator cancels out. So you can see that, yes, the only unit you are left with in this problem is calorie. And yes, what is the unit of heat? It could be calorie or it could be joule. So yes, the way you plug in the value or way you shuffle the equation, it is right. Now you all you have to do is simply multiply this number and find out the answer. Do you understand?
Yes.
Everyone?
Yeah, Professor.
Yes.
All right. So
Can you do the math?
yeah, can you do the math? And that's what I was going to say. Can you do the math and let me know what is the final answer?
233.
333?
233.
Yeah, 233.5.
233.5.
No, but we're using
0.5.
one significant figure.
Okay. So yes, so I was going to tell you that. So let's say if we are doing this, right? If we are solving the problem and let's say if I'm going to ask you, write down your answer in correct number of significant figure, what you have to do, you have to pay attention to this point, delta T, right? In delta T, I will not give you the temperature like 22 and 28. All right. I gave you that because it's simple, but in the exam, the way I'm gonna give it to you or any of your professor is going to give you is like 22.0 degrees Celsius and 28.5 degrees Celsius. So that way you will at least have one number after decimal place when you subtract this. Do you understand?
Mm-hmm.
The answer you are going to get after subtraction will look like this, which at least have two significant figures, right? When it has two significant figure, it will be easier for you to answer, write down your answer in two significant figure at least. All right, do you understand this? Or it can be given you like this: 22.00, in which you have four significant figures, and 28.50, in which you have also four significant figure. If we compare this, there is two number after decimal place, so your answer should have 6.50 degrees Celsius as delta T. If you plug in that value 6.50, it means you have three significant figure here, three significant figure here, three significant figure here, so you can have your answer as 2.30, like, sorry, 233 something. Get it?
Professor, can you see the chat? I calculate the answer, but I don't know how to write down the significant number.
Yeah, I
Alright.
don't understand either.
I confused about that.
Can somebody put something in a chat box, because I can't see right now, because every time when you type something, sometime it pops up and sometime it doesn't. Unfortunately, this time, like, this Zoom has to kind of correct this issue. I can't see.
It's 233.466. That's what's in the group chat.
Okay, give me 1 minute.
Can you read the significant number part of it, Professor, please?
All right, yeah, I can't see the chat. So what I'm gonna do, I'm just going to stop sharing this. Okay, I can just see. All right, so now I can see the chat. Okay, so it's like 233.466, right? Or it's 233.5. All right, so what we're going to do, let me just share a whiteboard with you so I can explain you this. Share a whiteboard. I think this would be easier. All right, so I do not remember the number, but let's try this thing, right? For example, okay, it should be dark. Let me just change the color. Black. Okay, no, just give me 1 minute, guys. This is acting weird. Stop. Go back. Whiteboard. Change this. All right, now it's good. All right, so for example, let's say this is calorie over gram degrees Celsius. You have mass, which is 28.5 grams, and you have a temperature change, which is 22, or it shouldn't be 22. It should be 6.80 degrees Celsius, for example. Okay, let me just give you something more challenging, right? So let's say 6.8 degrees Celsius. Okay. In this, like, can you just multiply this and give me the answer? What is the answer? And it would be nice if you can just say it, I can't see the chat box again, so.
3,236.46.
Everybody agree?
Yes.
Yes.
All right. So now, as you see, right, I think this was the question that you were having trouble with. So in this case, right, it should be calorie. Now, what we're going to see, we are going to see this is multiplication. So you have to look at the significant figures. The first number we have, it has three significant figure. Second number we have, it has three significant figure. The third number we have, it has two significant figure. Everybody agree? Yes?
Yeah.
Yes.
What does it mean? Your answer must have only two significant figure. Is that right, everybody?
Right.
Yes.
Right, so answer should have only two significant figure. So in this case, what you can do, you have to convert this into the scientific notation, or you can just round it off, right? In terms of rounding off, right? Let's try this rounding off. What does it mean? It means when it says two significant figure, it means you have only 32, but you cannot just say 32. What the other numbers that you have, you're going to round it off to the closest possible number. In this case, because the number that you are getting off is 36, which is less than, okay, I just focus on this. All right, let's just focus on the number that the digit that we are trying to get rid of. It is 3, less than 5, right? In that case, if we had to write down this in a two significant figure, we're just going to say 0, 0. So 3200 is your answer in correct number of significant figures. Why?
Could you express it in kilocalorie?
Yeah, there is another way you can do it. I'm going to explain you that. Let's say if I'm going to ask you the question that I will ask you the question saying that answer in calorie, right? You have to answer in calorie. Then what you're going to do? I'm going to explain you another way, right? So do you understand this? First of all, do you understand what I just did?
No, I do not understand it.
All right, so let me just repeat that, right? Let's say if you have a number like this, 3216. If I'm going to ask you convert that into three significant figure, what you're going to do, you have to get rid of the last digit. Everybody agree?
Yes.
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 If you have to get rid of the last digit, it means you have to round off. Because this number is greater than 5, it means you're going to add +1, of course, to the previous digit that you're going to retain, right? So the number should be 3220. This is 1, 2, and 3 significant figure. Do not write decimal place after this. And yes, this is the right answer, 3 significant figure. Why is that? Because this is 3216. If you have to round it off, the closest you can get is 3220. For example, if you have 3213, if you want to round it off, it should be 3210. Do you follow me?
Yes.
Yes.
Right?
Yes.
You cannot change the value, right? Let's see if I'm going to ask you one more time here, right? If you have to write this in three significant figure, what if you write 322, right? It may comes in your mind. Why don't we just write 322? Remember, if we are changing in a different number of significant figure, it means we are only changing the significant figure. We are not changing the value. If we write 3216 as 322, you see, we change the value, right? This is 3000. Now this is 300. It is not right. Do you follow me?
Yes.
All right.
Yes.
That is the reason you cannot just ignore the last digit, right? That's why it has to be 3220.
Professor.
Yes.
So then every time for specific heat questions, it's always going to be the only have two significant numbers, or it could be any
It
significant.
could be 3. It could be 3 depending on what are the numbers given to you.
Okay, but that's going to be based on the professor question, right? It's
Oh
not.
yes, it depends on the question. Yes.
Okay, thank you.
It depends on what values has been given to you in the question. Right? I still need to kind of explain you this part, right? Let's try this too, right? If we have this two number, and here we try to write this down in three significant figures. I think everybody got this. Let me just ask you, if you want to write this in two significant figure, how are you going to write this? 3216. Write down in two significant figures.
3200.
Yep.
Everyone, do you follow?
Yes.
3200.
When you say it's two significant figure, it means you're gonna keep the first two digit. You're gonna get rid of the digit this 1 and 6, right? The number that we have is 1, which is less than 5, of course. So we're just going to replace that with 0 and 0. And you see the value is still same, 3216 and 3200. It is pretty close. If you are talking about significant figure, it is pretty close, right? If you just want to write it as 32, of course incorrect, because you are changing the value from 3216, you are putting it, you're bringing the value like 32. Of course unequal, not same. All right, do you follow me, everybody?
Yes, sir.
Yep.
Yes. Yes.
That's great. So this is one way to do it, that is called round it off. The second way to do it is writing in scientific notation, right? I already explained you scientific notation, so I believe you guys can remember this. All right, so let me just ask you, if you want to write this number in the scientific notation in which it has only 3 significant figures, how are you going to write that? The number that we are working on, right? 3236.46. Write this number in a scientific notation so that it can have only 3 significant figures.
Thirty-two point four into 10 square.
32.4, then
10 square.
square. No, it is not just correct presentation. That's it. Sorry.
What was the question?
Can you write this number down in a scientific notation? The number that we have, 3236.46. I want you to write this in a scientific notation. Also, the scientific notation should have only 3 significant figures.
Is it 3.23 times 10 to the third?
Yeah, that's right. All right. So let me just explain you. If you have tried it, it's amazing, it's great. If you haven't, it's fine. Let me just explain you guys, right?
Or can I write 3.24 into 10 cube? 10 or third?
Yeah, that's right.
So please write down, okay?
It should be 3.24 times 10 to the power of 3. But I'm going to explain you this here, right? So number that we have is
All right.
32.46, right? First of all, what we're going to do, we are going to convert that into scientific notation. What does it mean? When we write scientific notation, the decimal place has to be after the first non-zero digit. It means you have to move your decimal place right here. All right. Do you follow me? So the number is going to look like 3.23646 times 10 to the power of 3. Do you understand?
Yes.
Yes.
All right. So once you write that down in scientific notation, the second thing you have to do is look at how many significant figure you want your answer in. That's it. 3 significant figure, just focus on the first 3, right? The digit you are getting off is more than 5. So you're going to round it off. 3.24 times 10 to the power of 3. You get it,
Yes.
right? So it is simple. All right, we are just following the rule, which is kind of rounding off and write down in a correct number of significant figures. Also, if we just going to ignore that part, right, what we see, it is going to be 10 to the power of 3 significant figures. This is one way to do it, which is scientific notation. The other way to do it is rounding off. All right, if I'm going to ask you this number, right, again the same number, 3236.46, I am going to ask you, write down this number in a 3 significant figure following the rounding off rule. You want to round it off in a such a way that you get 3 significant figure, what that number should be.
3240.
You agree?
Yeah.
Right, 3 significant figure, it means this 3. The digit you are getting off is 6, which is of course more than 5. You're going to add 1 to this, so it should be 3 2 4. And of course you don't want to change the number. You're gonna, yeah, I would say, like, you don't want to change the value, so it should be 3240. Isn't that the same thing? Yeah, either you can call it 3240 or you can write down 3.24 times 10 to the power of 3. Isn't that the same thing?
Yes.
Yeah.
Yes.
Yeah.
Yeah, make sense? Is that clear to you guys?
Yes.
Yeah.
Yes, Professor.
Yes.
Yes, Professor.
Okay, that's great. Any question?
Excuse me, can I ask you something, Professor? So if this number was the number that's 232, if the number behind it 3 was greater than 5 or 5, would it be 3300?
Okay, let's try that. Okay, just give me 1 minute. I'm gonna erase this and make more space. Yeah, go ahead. What was the number?
Yeah, the number we are just doing it 323646. If the number was 325646
325646. Okay,
and we
let's
were
try.
to do the same with two significant figures, what would the number be? Just
All right.
curious.
Yep, let's try that. Everybody, I want you to convert this number into significant figure, right? What do you think it is going to be?
Which way, rounding off or scientific?
Any way you like, right? Doesn't matter. Or let's try both, right? Let's try round
200.
off, and second we're gonna try scientific notation. In terms of rounding off, what do you think the answer is going to be?
3200.
0.
3,300.
33.
Yeah, I agree.
33,
3300.
Everybody, right? So,
3,300. Yeah.
all right, let's just focus on this. We have two significant figure. It means this two. The digit you are getting off, it is 5. So if it's 5 or more, you have to add
Oh,
1.
3300. Yep.
Is 3 and 3. And of course, you don't want to change the value. So you're going to put 0 and 0, right? Because this is 3256. Now it looks like 3300, which is pretty close. It has two significant figures. Do you follow me, everybody?
Yes.
Yes. Yes, Professor.
All right. For significant figure, like scientific notation, what you're going to do?
3.3 into 10 power 3.
Yeah.
All right. I think everybody agree, but I'm just going to explain.
Yes.
56.46. When you have to write the scientific notation, it means you have to move your decimal place after the first non-zero number. So it should be 3.25646 multiplied by 10 to the power of what? You move 3 places on the left, so it should be plus 3. This is right, but now we just need to focus on significant figures. We just need two significant figure. It means this should be this. The number we are trying to, like the digit we are trying to get rid of is 5 or more than that. It means we're just going to add 1, right? So it should be 3.3 times 10 to the power of 3. And again, isn't that the same thing? Right?
Yes.
The value.
Yeah.
So it's not hard, you just need to understand that. We did not talk about rounding off, so I kind of skipped that when we talk about significant figures, but I think it's a good that we discuss this right now. All right. Do you guys have any other question or confusion in this concept?
No.
I think no.
Everybody?
No, Professor, it's all good.
Clearing that up.
All good? Everybody?
Yeah. So far.
We just need practice.
Of course. It's way too early for you guys. We have you guys have like entire one semester to learn this stuff, and you are learning it right now. So of course it's an advantage.
Professor, I have a question. Well, I'm pretty new in this class, and the way that we're gonna be practicing all these problems, that's the teacher on charge of the class is gonna be given a certain amount of problems, or we're gonna go into any program like similar to Lumen-O or any other kind of software.
Yeah, so there is one common practice that everybody do is like a homework. So they assign you the homework for each chapter. So it's like an online homework in which you just kind of, there could be like 10, 15 questions depending on which professor you took. So there could be like a 10, 15 question which you need to answer in certain period of time. Some professor give you like entire semester to finish your homework. Some professor give you like, different deadline for each chapter. So it depends on the professor. So that is one way to do it. The other way to do it is like sometime your professor like to give you like more practice problems rather than other than just homework, right? I like to do that. So I kind of share handout with different kind of problems to the students, and I also share the answers with them. So I just want them to practice. If they don't have to show me any work, of course, there is no point for that as well. But it's just for the practice. Somebody, if somebody is interested to practice and kind of make sure that they can finish the problem and solve the problem in a certain period of time, they can do that. So that is also that way. Another way is like generally depend on your instructor again, but they like to discuss this kind of problem during the lecture to explain you that how to solve this. Some professor may not do that, but probably I think most of them will do it. So they will explain you how to solve the problem, how to write down the answers and stuff.
Thank you very much.
Yeah.
Professor.
Yes, go ahead.
So then, back to that specific heat question. So if the answer is 324 calories, that is the answer to the specific heat. You'll just put specific heat equals 324 calories, and that's your answer.
It was a heat, right? It wasn't specific heat. It was just a heat, the value of heat. You remember the question from the question, right? We needed to find out heat because the value of the specific heat was given to you. So in that case, the answer, it could be, let's say if we have three significant figure, it could be 3240 calorie. So you just remember this. This is value of heat. If it's specific heat, it should have the kind of the unit like calorie over gram degree Celsius. You understand?
And then the heat one was heat over mass delta T.
Okay, let me just repeat that. Clear all right. So the formula is like this: specific heat is equal to amount of the heat that is required to increase the temperature of 1 gram of substance by 1 degree Celsius. In the problem that we discussed, the value of specific heat was given, the mass was given, and change in the temperature was given. So what we did, we kind of cross multiply this only on one side. So the formula, when we rearrange, it looks like specific heat times grams per degree Celsius is equal to heat. This is the formula we solve. We plug in the value of specific heat, we plug in the value of grams and degree Celsius. So when we do the math, we get our final answer. Let's say it is 3420. The unit is going to be calorie is equal to heat. So this was the answer. This is what we're supposed to get. Does it make sense?
Yes.
Somebody who asked me that question, do you understand this? Did I answer your
Oh,
question?
oh yes, yes, you did. Thank you, Professor.
Okay, great. All right. Anyone else? Any other questions for me?
No, Professor, thank you.
Okay, no problem. All right. So, with that said, we have like what, 20 more minutes. So I understand you may be tired, but I think it's good to continue. Is it okay with you guys? Do you want to continue, right?
Yes.
Yes, Professor.
Just have some tea, eat some dark chocolate, all right, and stay focused. We are briefly talk about the periodic table, right? I'm not going to explain you everything, but I'm going to explain you everything that you need to know at like within 20 minutes. All right. So whatever I can cover in 20 minutes, I'm just only going to talk about that. All right. So let me just stop this. Share my screen. Share the screen. Periodic table. So if you guys have the periodic table handy with you, it's nice. Please kind of have that hand, like look at your periodic table if you can see properly in the screen. So this is the periodic table that I sent it to you. I think everybody is kind of familiar with the looks of the periodic table. Are you? Have you seen the periodic table before?
Yes.
Yes.
Yes, Professor.
Yeah. Okay. So what I'm going to talk about, I'm going to talk about all the important point that you need to know from this periodic table. All right. First of all, if you look at the periodic table, what do you see? You see rows, right? Like horizontal rows, right? And the column. Everybody agree?
Yeah.
Write something on the screen. All right, I'm not sure. Okay, yes, I can write. but I cannot erase it, right? Yep, I won't be able to use it. All right, so the number that you see in here, 1, 2, 3, 4, 5, 6, and 7, what it indicate? It indicate how many rows you have in the periodic table. The rows in this periodic table is referred as period. All right, so that is called period. So you should remember this term. Every time when you learn this in the lecture, it will be called as period 1, period 2, period 3. All right, so instead of calling it rows, we are going to call it as a period. That is the first thing. Same way, you see the number on the top, 1, 2, 3, up to 18. Everybody?
Yeah.
Yeah.
Yes.
Yes.
Basically, we can generally call it as a
Group.
column, right? We call it as a column, but for the periodic table, we are going to call it as a group. So we're going to call this as a group. Oops. All right. So remember, every time you see this term group, you should know we are talking about column 1, 2, 3, 4, 5. Right? There is something more important for you to remember is what are the name of the group. We don't have to remember all the groups. We don't have to remember the name of all the groups, but certainly for certain groups, we do need to know the name. So I'm just going to highlight which group or column, right? We should know the names for. Group number 1, yes, we should know the name of the group number 1. Group number 2, we should know the name of the group number 2. The same way, the last group or the group on the right side, 18, we should know the name of this group. All right. Number 17, yes, we should know the name of this group. So basically, two group on the left side, two group on the right side, you must remember the name. What is the name? The first group name is
Alkyl metal.
metal, right? Alkyl metal. You see this name here? Alkali metal. All right. The group of the second name, sorry, the name of the second group is alkaline earth metal, right? It's group number 2. It means you can just remember it as there are two words, alkaline earth metal, right? Group number 1 has one word, alkali metal, right? Group number 2 has two words, alkaline earth metal. Group number 18, the last group, it is called noble gas. Why do we call it noble gas? Because those are the one which does not like to react or kind of form any compounds. They just are happy with themselves only. They don't like to interact with other people, right? Other elements. So it's called noble gases. And the second to the last group, which is group number 17, that is called halogen. I'm not sure why the name is not here. I'm just going to put this down here. Halogen. HALOGN. Group number 17 is called halogen. Do you guys understand?
Is it 17, Professor?
17, yes. Group number 17 is called halogen.
In the sheet you sent us in the email, it's 7A.
Sorry? Yes, I am going to talk about that. It is, there is two ways to number this column. All right?
All right. Thank you.
Yeah, so I'm going to talk about that. But at least the periodic table that you're seeing right now, the second to the last group, that is called halogen. The last group is called noble gas. The first group is called alkali metal. Second group is called alkaline earth metal. Do you understand, everybody?
Yes.
Yeah.
Yes. Yes.
So these are the four names you should remember. Now, if you look at the handout that I gave you, it has a different numbers. So what is that? I'm going to explain you that in here. So instead of having the group number starting from 1 to 18, you see that in here, right? It is 1, 2, 3, 4, 5, 6 up to 18. The there is another way we can number this group. What is that way? It is like this. The first group, we're gonna call it 1A. Now we have another letter which is A after the number. So 1A, it is group number 1A. Either we can just call it as group number 1, or we can also call it as 1A. Actually, there is two ways to label this group. This is the second way, right? Then it is 2A. All right, the second group is referred as 2A. Then this small segment, right, you see the smallest segment of your periodic table in the middle, we do not number this, right? We do not number this part. So this segment, which is like smaller segment in the periodic table, or the central segment, we do not number that. We directly move on to this group 3A. Do you follow me? Everybody can see this?
Yeah.
Yes.
Right, number 13, group number 13 is referred as 3A. Then you're just going to continue 4A, then 5A, then 6A, then 7A, and 8A. So this is another way to label the groups. All right, so now if you compare the table that, like the handout that I gave you, I said 8A is called noble gas, which is right. Or you can say group number 18 is noble gas. Group 7A is called halogen, or you can say group 17 is halogen. Does it make sense?
Yeah.
All right, so
Yes,
this,
yes.
sorry, any question? Okay, so this is very, very important for you to remember. There is two way to label the groups, right? Either you just write continuous number 1 to 18, or you write 1A, 2A. If you write it as 1A and 2A, you're just going to skip the middle section of the periodic table. You're not going to label it. All right, everybody can remember this stuff? Yeah.
Yes, sir.
Yes.
Okay, awesome, awesome. Now, what we're going to learn from this periodic table is each box you see in this periodic table, right? You see so many boxes in this periodic table. So just for your knowledge, you can, just for your knowledge, I'm telling you that the total number of elements that we are aware of, or total number of element we have in this periodic table, in the current periodic table, is 118. So that many different elements we actually have found out till now, right? Like as we discover more, we are going to add more. But now we have found out so many of them, there is less chances of finding few more elements. But yes, definitely in the future, we may be able to find few more. All right, so at the moment we have 118 elements. Now, what I want you to understand is each box in this periodic table is called elements. Would you remember that? What is an element? Every box in this periodic table is called elements. Make sense?
Yes.
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 Right? Okay, so please remember that every time when we refer to elements, you should know we just need to focus on each box, what we have in the box. All right. Now, let me just go back and share. All right, so what I'm going to say, keep this periodic table handy with you. I have to stop sharing this. I'm going to share whiteboard so I can write more stuff in here because I cannot write in here. So I'm going to share my whiteboard. All right, I'm going to erase this. All right, so what did we learn so far? Periodic table. We talk about each row is called period. Each column is called as groups. All right, in the groups there are two ways to number it, right? 1, 2 up to 18, and there is another way which is 1A, 2A up to 8A. There are 4 groups for which we need to know the names. I'm not going to repeat that, but I'm just going to write that down. 1A, 2A, 7A, and 8A. All right. Do you guys understand this part? Yeah. Everybody clear?
Yes.
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 All right. We are going to talk about this in the future, but I just need to kind of point out right now, why do we, what is the information we can get from the group? So basically, if you have a list of the element which is present in the same group, what does it mean? It means they have same properties. They act similarly. All right, same properties. We are not going to discuss more property about this, but just remember, just so you understand, the elements in the same group has similar property. They behave or act similarly. The other information we can derive from the group number is the way we have this group number 1 to in format of A, right? 1A, 2A up to 8A. What we can use or how we can use this information? We can know that how many, how to say that? Okay, I should say valence electron. All right, so we can find out number of valence electron from this group number. All right, of course we don't know what is valence electron right now. We are going to talk about that in the future, but you can remember this at least, that from this group number in which there is a second type of group number, right? 1A, 2A, 3A up to 8A. What that indicate? That indicates how many valence electron each element in that group has. So let's just assume that if you have any element in group number 1A, it will have how many valence electron? 1. If you have any element in group number 2A, how many valence electron it should have? 2. Do you understand?
Yes.
Yes.
Right, we
Yes.
are not going to use it at the moment. We are going to use it maybe on the in the last section, right? If we kind of get to that point, but at least you can remember this from this label 1A, 2A and up to 8A. What information we can extract from this? We can find out how many valence electron are there. Any, let's say if you have any F, for example, if you find out the element F in the periodic table, you will see it is present in group number 7A. All right, what does it mean? It means F, which is called fluorine, it has how many valence electron? Because it is present in 7A, we can say it has 7 valence electron. Do you understand?
Yes.
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 Okay, great. All right. All right, so moving on. Okay, so that we are going to use this in the future. Okay, just give me 1 minute. I need to find out something. All right. Okay. Now, I hope you guys have a periodic table with you. Yeah, everybody has the periodic table.
Yeah.
We do.
Everybody, yes?
Yes. Yes.
Okay, that's great. So I'm
Yes,
just
Professor.
show like a rough diagram of the periodic table. Of course, it's not exactly the right, but overall structure is right. All right, so the structure, like general look of the periodic table is something like this. Of course, much more better than my drawing, but something like this. So in this case, when you look at what other information we can extract or we can understand from this periodic table is, if you look at the element in this section, this part of the periodic table, in the printout that you have, you will see that has been labeled as M. All right, what it means? It means it is called metalloids. We are going to I'm going to explain you what is metalloid in a minute, but do you see that? Let me see if I have
Yeah.
it. Everybody can see
Yes.
that?
Yes.
All right. So there is like, of course, it's not exactly right, but it is that section starting with a B in here, right? If you look at that, it's like a zigzag fashion, like a kind of stair, right? That segment of the periodic table is called metalloids. Now, everything on the left side of that segment is considered as metal. Every element on the left side of this metalloid or zigzag fashion is called metal elements. Every element on the right side of this, right, everything which is present on the right side of the periodic table on this metalloid, that is considered or called as non-metal. Do you follow me,
Yes.
everybody? So this is the
Yeah.
kind of, right? So the first way we can describe the periodic table is like a rows and column, period and groups, right? The second generalized way we can kind of categorize the periodic table is metal, metalloids, and non-metal. Do you understand what I'm trying to say? This is kind of second classification. Okay.
Yes.
All right. So you don't have to remember the name of each of the metal, but this is the idea you should have, that anything on this zigzag fashion, anything on the left side of that zigzag fashion is considered as a metal element, right? Every box in this periodic table is called element. So all of that element is considered as metal element. Every box you have on the right side of this section is called non-metal elements. But there is an exception. What is that exception? Exception is hydrogen. The first element, which is H, even though it is present on the left side of these metalloids in the periodic table, hydrogen is the one element which is considered as non-metal element. So that's what you have to remember. All right, except
Professor,
just go ahead.
sorry to interrupt. As you can see, in the first group, yeah, the H, the one that you're explaining, right in the up on the down right corner, it has an N.
Yeah, it means it's non-metal.
Non-metal. Yeah, the same explanation is showing in the group that you were showing just a few minutes ago, the metalloid.
Uh-huh.
Each group has a name.
Yeah, that's what,
Yeah.
this is M.
Yeah.
Yes, I know.
It's just I just wanna clarify that, so some of us, we can have a better idea.
Oh, yes, that's great. Thank you so much. Yes, so when we call it metalloid, you can just look at the symbol M on the right bottom corner of that, like each box, you see the symbol M. It means it is metalloid. If you see a symbol which says NM, it means it is non-metal. All right, everybody, do you guys see that?
Yes.
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 All right, but in general you can just remember it this way, right? You don't have to identify each of them, as long as you know the zigzag fashion. If this is non-metal, it means everything on the left side of the periodic table is called metal except the hydrogen. All right, now let's just, because we just have like 5 more minutes, so I'm just going to talk about each cell that we have in the periodic table. All right, so I'm just going to take like 5 minutes and I'm going to explain you whatever I can. First of all, everybody should remember that the way we have arranged elements in this periodic table, it is based on the order of atomic number. All right, we are going to discuss this. Don't worry about this. We are going to talk about this on next Thursday. But just so you can remember this, right? The way we have arranged them, it is based on the order of the atomic number. So if you look at the first element, it has number 1. If you look at the one on the right side, it has number 2. As you move down the like period, right? You see number 3, you see number 4, right? And so on, 5, 6, 7, 8, right? You just continually saying the number which goes up by 1 digit. Do you see that?
Yes.
Yeah.
Yes.
All right. So this is something just for your understanding that the way we have categorized the periodic table or we have arranged the periodic table is based on the atomic number. Now let me just talk about the last point. If you see each box, again, I will just like to remind you that each box in the periodic table is called element. In this each box, what do you see? You see a number, which is, let's say, 1, for example. You see the symbol, right? So this is the symbol for an element. You see the name of the element, which is hydrogen, and you see another number at the bottom, which could be like something like this. All right, this is the basic information you see in most of the periodic table. I just want to point out what this information means. The number that you see, which is a kind of whole number, right? It could be 1, 2, 3, 4, 5, 6, 17, 18, whatever it is. The whole number, that is called atomic number. I'll just number. Let me just say it. All right. The number that you have, which is whole number, which does not have any decimal place, that is called atomic number. The number which it has a decimal place, right? If you look at all the boxes in the periodic table, there is number at the bottom which always have a decimal place. What is that? That is called atomic mass. Atomic mass. It means the weight of that atom. Or sometimes it is also, like many times it is also referred as mass number. All right, so we're going to refer this as both of this, atomic mass as well as the mass number. So there is a difference. What is atomic number? The whole number you see on the top, which goes up sequentially across the periodic table, that is called atomic number. The number with the decimal place is called mass number, or you can also call it as a atomic mass. Do you guys understand this?
Yes.
Yes.
Everyone, do you understand? You follow me?
Yes.
Yes, Professor.
Yes. Okay, great. So I
Yes.
think, all right. All right. So I think we have like a lot more to talk about, but because of the time limitation, I'm just going to stop at this point.